All right, now for problem 7. This is our Doppler effect problem. There will be one on the test. I think it's the same one we did earlier, but let's go over it again here with different numbers. So we've got two cars. We've got a traveler going north, police car headed toward us, coming south. Two different velocities emitting a sound, and the observer is going to hear a different sound than emitted by the police car due to their relative motions, or due to their motion in the air. This is the formula that we said would cover all the cases where that's the velocity of sound, velocity observer, velocity of the source. The police car is the source. Now the trick is to decide who's toward and who's away because of the way of how I've worded that equation. So you sort of think about them being relative to the air, and the way you do that is you ask, is one approaching toward or away while the other one's still. So the police car is headed toward the car is headed toward the police car. That's easy. The police car is our source, the observers in the other car. So since they're both toward, we pick the upper signs, which is plus on top, minus on bottom. And so we get out a frequency. That frequency is a little higher because we're both sort of compressing the waves when we saw the simulation. All right, now once the police car passes, then the car is moving away from the police car, and the police car is moving away from the observer. Therefore, we use the lower signs, and if you go back and look, that's your minus and plus. And so now the wavelengths are longer, which gives us a lower frequency. All right, and then he wanted us to do it where the police car is coming up behind us. So in that case, the car is moving, it's not the relative speed, but it's relative to the air. So the car is moving away from the police car, if the police were still, and the police are moving toward. So we have to use the lower sign on the top one for the observer and the upper sign. And so if we go back and look, lower and upper gives us two minuses. And we get a net lower frequency. Now here, I'm sorry, net higher frequency. All right, and down here, once he passes, then things are swapped. Now the car is moving toward the sound, the source, and the source is moving away from the observer. So we use the other two signs, and that gives us a little bit different frequency. So that's the Doppler shift. And again, you ask what one's doing if the other one were sitting still. This is the easiest way to figure out whether it's toward or away. Hope that helps, and there'll definitely be one of those on the test.